the one, the only, Chris Anderson.
So in the spirit of the 10-year anniversary, I thought we would declare the maker movement dead, and figure out what's next. Kevin Kelly from one of the co-founders of Wired magazine is here in the audience. He was my mentor on this, and so the Wired kind of formula was X is dead, Y is the future. And you could almost do that for anything. X, of course, is never dead, and Y is never the future. But it's a nice way to sort of think about what's next. And so I've been. This is my 9th Maker Faire. I'm embarrassed I missed the first one. But I've got to watch the trends overall, and I think we're on the verge of what I'm going to call, in a poverty of imagination, Maker Faire Maker Movement 2.0. And I'm going to talk a little bit about what that is. But I'm going to start with just a reminder of not quite 10 years ago, but 2007, 2 years into this was the big year. The Maker movement actually grew out of kind of a sense that DIY was going to be cool, and that there was something happening in the garages of the Bay Area that needed to kind of get out. It was a little bit of the web's community just realizing itself in the real world. But around 2007, a technological advance kicked in that suddenly made this real. And that's, I think, when the Maker movement really took off. Now, that was the year that a bunch of things we know today came out. It was 3D printing and the RepRap movement. It was Arduino. Massimo Bonzi is here in the audience as well. Make Magazine, Maker Faire was now a year old. There was the Wii controller. Now, the Wii controller may not feel like part of this, but there were people like James Park who bought a Wii controller and had no interest in playing the video games, but instead were saying, why is it that when I move the stick, this thing moves? What's inside here? And the answer was sensors, accelerometers. And they went on to say, well, what else could I do with those sensors? And they came up with Fitbit. And then there was the Lego Mindstorms, which is the robotics kit that also had sensors, and that's how I got started. And then most importantly, it was the iPhone. That was the year the iPhone came out. And what really happened here was a combination of some enabling technologies, especially the ones inside the smartphones, the sensors, the fact that these processors, this electronic stuff was now being made in the hundreds of millions by the Apples and the Googles, et cetera. This led to a disruption in the force, a disturbance in the force, a glitch in the matrix. There was suddenly stuff that used to be hard got easy. A lot like the Homebrew Computing Club in 1977, where a chip, the 8086, if I'm not mistaken, came out, and suddenly two guys, Jobs and Wozniak, realized that you could do something with this. The iPhone guts, smartphone guts, along with these other things, started to feel like you could do something with this. Now, these were the enabling technologies. Around this, there's 20 years of open innovation, the web's communities and open source and all that. The combination of those two, I think, defined the Maker movement. So my little path on this was that I got Lego Mindstorms, I came to Maker Faire, and I thought, well, what could I use the sensors for? James Park and team did Fitbit, and I did drones and flying robots. And so this was our first production line with the children, and we paid them in strawberries and juice. And this is what we made, and it was very, very Maker movement-y. Those are pizza boxes. It was a robot blimp. It was based on Arduino, and learned important lessons like the worst thing that can happen if your children are your workers is that you actually sell out, because then you have to do it again, and they just won't do it again. So I got a guy to do it. I met on the internet, a guy to do it again. And this, again, is very Maker movement. We are really right here. This is a classic garage, children, dining room table, soldering things together by hand. And that's how we got started, and that's how we thought it would end. And the big lesson for us in this, the reason that we got interested was not because we knew a lot about technology or about robots or about drones, etc. It's that we learned a social lesson, which was that we chose a community, we chose a movement, we chose Arduino. Now, Arduino was not the most powerful chip out there. It didn't have the feeds and speeds, but what it had was the best community. And that is the lesson of the Maker movement, is that you're going where the people are going. You're following the the herd, if you will, because that's where the energy and the libraries and the code examples and the help all exist. And it turns out that social forces are much more important than technological forces. So we just followed the bandwagon, and we extracted all the social lessons from the 20 years of open innovation that come before, added it to these new hardware things that become easy and cheap. I mean, that the guy I showed you before, Jordi Munoz, my co-founder, his instinct was that Arduino was the right way to go. Why did he think it was the right way to go? He's a 19-year-old in Tijuana. He said it's because it's cheap. Now, you don't think generally it's cheap being the sort of guiding principle of what you should choose. And he said, oh, and by the way, it's also easy. But cheap and easy equals more people. But cheap and easy is a social force, and that's why it became the big movement it was. So that notion of community beats technology, I think, is intrinsic in the maker movement, and that was the lesson we drew there. Now, you fast forward a few more years, and suddenly we're this, and we're this, and we're now a big company with lots of venture capital and factories and things like that, and we're now out of the maker movement. We used to have booths here. Last year we had a booth here. Now we don't. Now we're a big aerospace company. But that's kind of amazing that we could go from my children, around the dining room table, from a teenager in Tijuana to a massive aerospace company in just a few years. And the answer is not because we're so technologically brilliant. It's because we had a lot of help. Because suddenly things got easier. That was the essence of the maker movement: is the social forces that we could harness. So, and this is the kind of stuff we make, and these are now sophisticated consumer electronics devices. This is a drone called Solo that's coming out in a couple weeks, and this is the lesson of coming from the grassroots, as we did from the maker movement, which is that we're not a 747 minus the pilot. We're a smartphone with wings. And when you come at this from the maker movement, from the grassroots, much as Jobs and Wozniak did, once they realized that it was not a big business machine, but rather a desktop machine. Once you introduce the notion of consumers or amateurs, suddenly you recognize that this could do much more. And once we realized that a drone was just a phone with propellers or wings, then we realized it was part of the cloud. It was part of the internet. It was part of the Internet of Things. And so we actually thought about it entirely differently. And we just sort of think of it now as part of the cloud. And it's now just another node on the cloud. It's an extension of the internet. It's a connected device. And so, because we came out of this community, we understood that community matters most, and we understand that the community is on the internet, and that everything else is essentially an extension of the internet. And so we architected drones as if they're just a little sort of tendril out from the cloud, rather than a standalone flying device. And so this notion that the trends, the big mega trends matter, is how we beat big companies. We realize that there's this convergence, that smartphones and drones are really the same thing, because they're starting to use the same chips. We realize that Linux, which looked like a server software, is now becoming smartphone software, and then must, by extension, become drone software. And then you realize that the things like academic projects like the robot operating system, which looked like it was out there in another community, are actually part of the same community. And these circles here are not circles about technology, they're really circles of people. These are lands, these are continents that are starting to come together. And what you're seeing is this sort of tectonic collision of continents that have been working on their own, but as technology brings them together, bridges these continents, now these communities are one. And now we have this amazing force amplifier by which all the things we're working on now turn out there's like thousands of other people who are also working on something very related, and if we could only find that bridge, we can all share each other's work. Exactly like the web. We're making hardware look like the web. So this is my favorite book from high school, Flannery O'Connor's Everything that Rises Must Converge. It's a book of short stories. It's actually not her best book, but it's her best title. And this is the lesson: everything that rises must converge. What you're looking at here is just rising. What you see around you are just lots of people working on things, and you can almost intuitively sense what's rising, what's hot, what's more of this year than there were last year, what's new this year. And you know that because we're all here, they're all going to intersect. These communities all become one community, and that really is the lesson of the Maker Movement. So now I'm going to explain the difference between then, the Maker Movement 1.0 and 2.0. These were some of the enabling technologies of the Maker Movement. Arduino. What was great about Arduino was not just that it was easy to use and it was cheap, it was also easy to hack. That anybody could get the board, and there was something called Eagle, which was a PCB design software that was free and you download, and anybody could make their own Arduino board. I did it, many people did it, and it was sort of accessible. 3D printing using FDM, which is that sort of squeeze-out plastic thing, was also accessible. You saw examples of it before. Laser cutting, also accessible. These things were all sort of within the reach of regular people. And that, I think, that lowered the barriers to entry and made the Maker Movement as successful as it was because the tools and the technologies were easy enough that anybody could do it. Now, that's great, but unfortunately, there's this consequence, which is that as more and more companies have come out of the Maker Movement, and as the technologies of things like desktop prototyping and electronics have gotten more sophisticated, as these continents have converged, suddenly we're starting, if you're using smartphone guts, if you're using smartphone chips, now you're dealing with really hard stuff. These are multi-gigahertz chips running on six-layer boards. This is not the kind of stuff that regular people can use anymore. The beauty is that it runs Linux, and so it can do so much more, and we now have all these other tools and libraries and packages available to us. But the bad news is that we can't hack the hardware as well, because it's just too hard. And so what you're seeing now is a kind of a divergence, I think. It started here in 2007 with all this laser cut stuff, and that was great. And then I blame Pebble, and I love Pebble. I'm wearing a Pebble right now. But Pebble was one of the first companies that came out of the Maker Movement that really was polished and could compete with Apple, and is in fact competing with Apple, and sort of looked like a consumer electronics device rather than a bag of parts. And now today, to be a successful Kickstarter project, you need to be polished. You need to look like a consumer electronics product, which means you need industrial design and manufacturing experience. And I realize that we got away with murder back in those early days, that Jordy and I were able to have that factory with my children, to hand solder things, to have years of shipping bags of parts that you had to solder and code that you had to compile, etc. And those days, at least from a commercial side, may be gone. It's just not okay to ship a bag of parts anymore. People expect consumer electronics polish. So we're seeing the pros kind of going off into what looks like traditional consumer electronic stuff, and they're going to Shenzhen, and as a matter of fact, Shenzhen's representing a lot of this. Now that's fantastic. That's great. You get more, the barriers to entry to that world have fallen. You get more innovation, you get more products, it's all happening faster, it's great. But it's not really the Maker Movement anymore. Meanwhile, I think the Maker Movement, at least on the hardware side, is sort of returning to more of its roots. This notion that everything out here is a company waiting to form, that actually probably is not the case anymore. Many of them are now going back to education and tinkering, while the commercial side goes to Kickstarter and venture capital and beyond. So this is what I think are the enabling technologies of this new Maker Movement, the one that has now grown into the smartphone technologies. Rather than Arduino, which I love, we're now seeing Linux, embedded Linux. It started with things like Raspberry Pi. There's an astounding chip on Kickstarter right now called Chip, which I'll tell you about in a second. But we're realizing that this kind of hacking at the core levels, that's probably not where we're going to be. We should all learn Linux now. This is the next renaissance of Linux. It's now embedded Linux rather than desktop Linux, but it's basically free. We get Linux for free. These chips cost no more than Arduino, and they run full-on operating systems. And so we're now switching to the software side, where the chips are just inherited from, whatever, the Qualcomms of the world, and we actually focus on the software. Rather than regular 3D printing, we're seeing CNC get really interesting. CNC is the subtractive side. It used to be super, super hard with complex industrial software and dangerous machines. And now I think you're seeing that rise. And then finally, on 3D printing, you're starting to see a new generation, SLA with lasers and things like that, which open up new materials and resolutions and speeds that we didn't see before. All these things are fantastic, but they are all harder to use than the ones that came before. So just running through them really quickly. I think that Linux is probably the understated trend out there. We've been so focused on this sort of Arduino era, and we loved it, and it got us here. But I think in sadness that this notion of writing straight to the iron is ending. And even Arduino is now embracing Linux. What this means is that we now have operating systems. There's these incredible packages out there. You can plug in USB things rather than plugging in standalone sensors and things like that. And these things now look like laptops. And that's super exciting because there's so much work that's been done out there in Linux, and it's all there for the taking. We don't have to reinvent the wheel anymore. This, $9 for this board right here with a gigahertz processor, 4 gigabytes of data. This is astounding. It's just the bounty of the economies of scale of Shenzhen are just amazing. There's the ESP2866 module out there, which you're starting to hear more about. This is like Wi-Fi, plus an ARM processor, plus servers, etc., essentially for free. I mean, this is less than a cup of coffee. And this stuff used to be super hard, and you can just now assume it's free. Assume Linux is free. Assume Wi-Fi is free. Assume Bluetooth is free. Let's move up to the next layer. Assume all the computational and hardware stuff is essentially free. Now, what are we going to do? And now it starts to look more like software. I mentioned CNC getting more interesting. This is actually where I'm focused right now. I think that CNC has essentially been a software problem. It's too hard to use. And you're seeing companies like Inventables, who do the Carvey, and other Machine Corp, who did the other mill. These are companies that are really thinking at it from a software perspective. How do you make CNC, subtractive manufacturing, as easy as 3D printing? Because once you do, you have all these materials that you can suddenly use, metals and woods and really interesting plastics and composites and things like that. You can make molds, not just products. Once you make a mold, then you can mass produce things. And all of this has just been held back because CNC was stuck in the ancient manufacturing past. I think we're about to see a software renaissance that makes it look like the new 3D printing. Once you move to these new, more sophisticated devices, you can explore new materials. I mean, the one up here on the right is using printing with living cells. And then this machine right here is printing with inks that are conductive and non-conductive. And you can actually print circuits and layers of circuits just with a 3D printer by using more interesting materials that go into it. So I think you're going to start to see a new materials renaissance out there as well as we start with the tools we had and move past the plastics, the ABSs, and the PLAs. One of the most interesting trends I've been watching is just the rise. So there have always been these two movements. There was making and there was crafting. And making was kind of a guy thing, and crafting was kind of a women thing or girl thing. And now what we're seeing is a real convergence. The DIY movement, if you look on YouTube, it's mostly what people used to call crafting. I've got 5 kids, 3 girls, 2 boys. The girls are much more interested in this than the boys. Because they see more role models, the tools are more fun, you're using a more range of materials like papers and fabrics and vinyls, etc. I think Carl Bass earlier showed the Cricut. But this Cricut right here, you may not know this machine, but you should. This is a CNC machine. It's a CNC machine that does cutting and plotting. It's got a blade and it's got pens. And it's much easier to use than most 3D printers. It's beautifully made. Of all the machines we have in our house, the CNCs and the 3D printers and the scanners, this is the one that gets used the most. This one has become the gateway drug to making in our house. And it's made by a company out of Utah. They've been around forever, but you didn't think of them as being part of the maker movement because it came out of papercraft. And yet, once again, everything that rises must converge. This now looks like a kind of a really polished CNC machine. And it's opening up the maker movement to a whole new class of makers who aren't necessarily interested in electronics, but are interested in the art side of it. When I look at the gender split out here, it's now, I think there's probably more girls than boys, which is a shift from the early days and could not make me happier. This, by the way, is my daughter's favorite DIY site is Laura DIY. But these YouTube stars using DIY are inspiring a generation of kids in a way that we geeks maybe never could. So this is the last thing that we're doing, which is sort of, I think, what gets really interesting and taps into some of the things Carl Bass was saying earlier. So the internet, the last 20 years, have been doing this amazing job of digitizing our screen lives. And what you measure, you can manage, and that's great. It's the cookies and the statistics and big data and all that. But what the real point of the maker movement is to extend the internet out into the physical world. And this is what we call reality capture. And this is actually what we do with drones. Drones are the new satellites. Drones have the ability to see our world and measure our world and capture our world much cheaper, higher resolution, more often than satellites can. Satellites sort of glimpsed the world from above, but drones allow us to give almost infinite resolution, infinite texture, and almost sort of fractal ability to digitize everything around us. Google has Street View. Drones are going to bring us Sky View. And this is called reality capture. And this is just an example of what happens when you fly a drone around a building and you take pictures with a GoPro camera. You get this kind of resolution back. This is using Autodesk's recap software and our drones. And we now have the ability to essentially get photorealistic scanning. Photorealistic digitizing of anywhere, anytime, at no cost, and we can map it onto the underlying maps or CAD files of the world, and things like this are where things get hard, and because there's the complicated objects with weird structures, etc. But as we bring the drones in, bring humans into the loop, and bring them further in, the drones further close to the ground in a safe way, we can even scan these things perfectly. And that's where it gets interesting, where we have the ability to take the internet, put it out to the world with the maker movement's technologies, build the communities of interest that are bridged with these technologies, digitize the world, measure the world, manage the world. You're just seeing one little thing here, which was construction and architecture, but it also extends to agriculture. It extends to the environment, weather, and beyond. And so I think that, what we're really seeing now is as we've matured from this first generation of the maker movement, we were tinkering, to a level where we have the tools, professional tools, at $9, at $3, within the reach of regular people, we're going to be able to take this and have an impact on the planet that we never would have before. On one level, it means that it's not really tinkering anymore. On another level, the same thing happened with the PC. Jobs and Wozniak graduated from the Homebrew Computing Club, and the world was better for it. And I think what we're seeing is the moment when we're going to do the same. Thank you very much.